Assalamu alaikum everyone. So today we're going to start a new topic, which is file incorporation management, and while we're at it we'll also learn how to use or how to compile C programs using the command prompt. Okay, so let's start. So the command prompt actually is sort of like a terminal for the operating system. Okay, so whatever you have to do in the command prompt, you have to do using commands instead of a graphical user interface like the desktop or the file explorer. Here you have to work using commands. So what we are going to do is, instead of using an IDE, which is the code blocks, we will use the command line, and the command line use the same compiler as code blocks, which is GNU. So if you know where the code blocks is installed, you will see that there's already an application installed there, which we will be using from the command prompt. Okay, so at first what we have to do, we have to call the main function with or without arguments actually. So if you can remember, we learned two types of main functions, one with arguments and the other one without arguments. Okay, and previously we could not call the main function itself as the operating system used to call it, but now we will be calling it ourselves, so we can actually edit or use the arguments. So how to execute the program? At first we have to go to the command prompt using the Windows key plus R. Okay, so if any one of you is using any other operating system, there are separate ways. For example, in case of Linux, you have to just go to the application terminal. Okay, and in case of Windows, you have to give Windows key plus R to call the run application, and in the run application use the CMD command, which is the command for command prompt. Okay, so once inside the command prompt, you can use the CD to change directory, to go to the directory where your program is. Okay, and then use the GCC command for compiling. Okay, afterwards just call the executable file to run it. Okay, so I'm going to show you a demo. So I'm pressing Windows R now, and as you can see, the run application is being shown, and here the command is CMD, so I'm giving OK. Okay, so now this is my command prompt, and as you can see at the very left part, okay, so I'm going to increase the size. So you can change the font of the command prompt whenever you want. So I'm increasing the size to 24. Okay, so I guess you can see now. So at the very top left, you will see that, okay, not top, the third line, you can see that the address is given. This is where my command prompt is currently. But where do I have to go? I have to go to the place where the files are. Okay, so all the files are here. These are all the files that will be running today, or all the C programs. So what I have to do, I have to go to this directory or this folder. Okay, so as you can see at the very top, this drive is actually D. Right at the top you can see in the location, but we are now in drive C in the command prompt. So the command for changing drives is just the name of the drive. For example, D, then colon. So as you can see, the drive has been changed. If I want to go to E, then E and then colon. Okay, so we want to go to D, so we're going to D. Okay, now once we're inside D, then we can actually go to the file or folder using CD or change directory. Now we have to give the address. So what I'm going to do is, I'm going to just copy the address from here. Okay, so I'm copying it and then pasting it here. Okay, so if you are not able to go to a location, then it will give you an error. For example, if I change this FIL, there is no folder like that, so it's saying that the system cannot find the path specified. Okay, now I'm going to use the correct one, and see, now it's inside, because as you can see, the angular sign, this angular sign is now at the very right of the whole location. That means we are now inside this location. Okay, so if you want to see the contents of this file, just press dir or directory. Okay, so you can actually do everything that you can using a file explorer. The same things you can do inside a console or terminal or command prompt in Windows. Okay, so this is the information given of this location. So as we can see, all the information is given here, and whatever files we have seen, they are already in the command prompt and also here, right? So basic.c, binary, copy, copy, hello, hello, higher level, ref copy, here's ref copy, then random access is also there, then stdc, right? But there are two other things. There is one dot and another two dots here, right? So even if these are there, these two things are not in the folder, right? So what are they? They are extra links to the previous folder and the current folder. So this dot is a link to the current folder, and these two dots is a link to the previous or the parent folder. So in our case, the parent folder is the codes. Okay, so you learn more about how to navigate or work using command prompts in your later courses, especially in operating system course. But for now, I'll just show you how to use it to compile your programs. Okay, so the command for compiling programs is gcc. Okay, so after gcc, I have to write the name of the file. So I'm going to run the hello program. Okay, so let's just see what the hello program contains. This is the hello program, so which only contains one line, the main function, and then inside that one line, which is printf hello world. Okay, so if this is printed, we'll understand that the program is running properly. So let's go back to the command prompt and gcc hello.c. Okay, so now it's being compiled. So after compilation, is there any change here? Yes, you can see that the change is a new file has been created, which is a.exe. But is this the file that we want? Because the name is different. Let's see. Yes, it is the file we want, because just as we called a, this is how you can call an executable function. Okay, so whatever executable function there is, you just have to write the name, it will be executed. Okay, so now we executed the a program, which is hello world. Okay, and it's printing hello world properly. But the confusion here is whenever we compile C file, the a program will be replaced, right? So what we can do is we can write this line gcc, then name of the program, name of the code, then -o, which is an option for us to actually give the name to the program. Then we can write hello. Okay, so after this, if we see here, we'll see that now there are two programs, a and hello. So this is the new program, which is actually similar to the program a, but with the name hello. How, or is it actually true? Let's just see. Hello. So it's working properly, right? So now what we can do is we can delete this one, because we don't need any confusion. So this is the hello program. Okay, so whenever you want to compile any program, just use this line gcc, the name of the file or code that you want to compile, then -o, and then the name of the program that you want to give it. For example, if you want to change or give it a different name, you can also do that. Okay, so remember, there are always spaces in between all the words, okay, or arguments. Okay, so let's get back to our slide. So this is how actually you can use command prompt to execute files. Okay, so let's move on to the next slide, which is streams and devices. Okay, so the input output system of C provides a consistent interface or abstraction to the programmer. Okay, so what is an abstraction? So we'll understand that now. So this abstraction is the same for all sorts of input and output devices, and is called a stream. Okay, and abstract means something without a physical form. Okay, so this is the dictionary meaning of abstract. Abstract means anything which does not have any physical form, but in computer science it's something different. So let's see an example, then we'll understand. So suppose you have a code and you want to print something on the monitor. Okay, but do you have to handle all the specifics or all the technical details of a monitor? Because if you remember, you only write printf, right? So just writing printf is printing to a monitor. Is it supposed to be that simple? Actually no, there are a lot of things that you have to configure, a lot of things that you have to say to the monitor to actually make it print something or display something, but all of that is handled by someone else, right? So this specific thing we call an abstraction. So an abstraction actually makes it very easier for the programmer to code, because he doesn't have to think about all the little details or all things that he doesn't know about. he can only write something or work at the upper level. Okay, so in our case, in this case, when we are writing or printing something using the operating system on the monitor, our abstraction is the operating system. Okay, so now if we go back to our slide, in this case we are using C to access the input output system, right? So in this case the abstraction is different, right? So this abstraction is called stream. So if you can see the very right figure, the coder is you, which is at the very top level of the architecture, and you can always see the same interface because you are just writing things, right? You're just writing in code blocks in IDE, so you will see the same thing, but it will not be any different to you, whatever may be the input output system. Okay, and in the middle is the stream. The stream is something of C which handles the differences, which is why you see the same thing. So you can call the stream as a logical interface to a file. Well, actually not a file, it can be many things. Okay, so if you see the last step, then we'll understand. The very last part of this architecture is the device. So the device can not only be a disk file, it can be the screen or the monitor or the keyboard. Okay, so it can be many things, but in our case it's a disk file. So if you remember the previous figure, we said that the operating system handles it. Okay, so the work that is done by the program or the things that are which are already included in the library files or library definitions is stream. So this stream actually communicates with the operating system and asks for permissions like access to a disk file or access to a screen or access to a keyboard. Okay, so this is just the theoretical things. So let's move on. So whenever we want to use a stream, we have to link a stream to a file, because a stream can be linked to the keyboard, right? Or it can also be linked to a monitor. And again, when we're linking it to a file, we have to say which file we're linking it to. Okay, so this is done through an open operation. Okay, so a stream is disconnected or dissociated from a file using a close operation. So an open operation opens the stream and a close operation closes the stream. So once the open operation is done, only then we can work with the stream. Okay, so there are two types of streams, text and binary. Okay, so the text is, or the text stream works with characters or ASCII characters, you can call it. So the text streams considers the files as a series of characters. So whenever you take input or write something into the file, it actually works using characters and reads or writes from the file in terms of characters. So whatever might be in the file, you'll always get characters and you have to always write using characters. Binary stream, on the other hand, can be used with any type of data. So it can read the file as a series of ones and zeros. And if you can remember, the machines always communicate with zeros and ones, right? And the data is also stored as zeros and ones. So if you can read or write using binary, you can basically read any file or write into any file. So let's just see how the file operation or close and open operation works. Okay, so let's say this is a file pointer. Okay, so we'll see the code of file pointer later on, but just understand that this file pointer is something which can point to a file. So if we have a file, let's say file 1, and then we have another file which is file 2. Okay, so whenever we write an open operation, so this is the function for fopen. Okay, we haven't seen the function yet, so I'm just writing it in general or in an abstract way. So this means that we are just opening the file 1. Okay, so once we open the file 1, then the file pointer will be pointing to the file 1. Okay, so if it wasn't pointing to anything like this, that means that it is pointing to null, so no file was opened. Okay, so now it is pointing to file 1. Now when we write the close operation or f close, so this means now we have closed it and the file pointer is not pointing to anything else. Okay, so then again if we write another open operation, file 2, so now what will happen? The file pointer will be pointing to the second file. Okay, so this is how you can actually alternate between different files using the same file pointer. Okay, So now let's move on to the coding part. So this is how actually you can open a file. Okay, so a file is opened with text stream using a function with the following prototype. So remember, this is saying about a text stream. Okay, so file f open, then this is the name of the file. Okay, f name. So in the previous case it was file 1 and file 2, right? And this is the mode. Okay, so this means in which mode we are going to open. We'll see some many of the modes in detail, but if I want to give you a brief description, then this mode tells me whether I want to write into a file or whether I want to read from a file, etc. Okay, so here the function returns a file pointer. Okay, so this is what we are talking about. FP, that was the file pointer in the figure, right? So the data type is file. Okay, and it is already defined in a library. So this type variable can point to any position of a file. Okay, and the character pointer, which is f name, points to the name of the file, which is f name. Okay, so the variable mode determines which mode the file is being opened in. For example, read or write. Okay, a successful opening of a file returns the pointer to the opened file. So this pointer, file and asterisk for pointer, this function returns, or the return type is actually file, right? So this function returns the file or the pointing direction of the file which you just opened. And if you cannot open that file for any reason, for example, if you do not have permission to that file, then it will return a null pointer. Okay, so in this way you can actually check whether you are able to open the file or not. And as you are working with disks or actual hardware, you have to worry about whether you are able to open it or not, because there can be failure at any time. Okay, so the structure file and the macro null, this null is actually the null pointer that we were talking about, are defined in the header file stdio.h, the standard input output header file. Okay, so the file structure contains these information: the size of the file, the current location of the file, and the access modes, for example in read mode or write mode. Okay, and the location of the file can be actually anywhere. Whenever you just open a file, it usually points to the very beginning of the file. So as you can see in the figure at the right, the file pointer is here if no character is yet processed. But if you take some input, then the file pointer moves on to the next positions. And if, for example, let's say if you have read half of the characters, then the file position will be somewhere around here. And if you have read all the characters, then the file pointer should be pointing at the very end of the file. Okay, so the file pointer can point to any position of the file depending on how many characters has been processed. Okay, so this is an example code for opening a file. So as you can see, the first line is a declaration of a file pointer. The second line is an if condition which checks whether the file was opened or not. So fp is the file pointer, and we are assigning whatever return we get from this function fopen. Okay, and if that return is null, then this will be equal to null. Okay, so this condition will be true, and if it is not null, then it will be false. So as you can see, when it is null, we are saying that error opening file. We are printing this as an error message, and then we are exiting from the program. Exit 1 is the same as return 0. Okay, so it just stops the whole program then and there. Why do we need to do this? Because if you want to access some file which we have not yet been able to open, then what will happen? The program might crash. Okay, and as we are working with hardware, you have to be very careful now. Okay, so then let's go into the function details. So at the very first part, or the very first argument of this function, fopen is the name of the file. So as you can see, this is how you have to write the name in quotation marks, because it's a string, remember. Then you have to write the name of the file, which is file.txt. So it is a text type file, then comma, and the second argument, which is the mode. So in this case, the mode is R, which is read mode. Okay, this also you have to write using quotation marks. Now one thing you have to understand here is that this part that we are using is actually a string or a constant string. Okay, but if you want, you can write a variable here also, as long as that variable contains the name of the file. Okay, so you can use this string or any other variable name, just like in strcpy or strcat. Okay, or catenation. So these are the different modes of opening files. So you can see more modes or how they work at the in chapter 9.2 of Teach Yourself C, 3rd edition. Okay, so this is the book that I followed, and as you can see, the name of the book and the detail is given at the very top as a header. So the modes are R, W, A, RB, WB, AB, R plus, and W plus. Okay, so what do each of these modes do? The very first one, R, which we have already seen, is mode for opening a text file in reading mode. Okay, and W is for writing, and A is for appending. What does append mean? Append means that whenever a text file already contains something, then in append mode you can add something to the existing text. Okay, and the read mode means you are just opening a file for reading, and to use read mode the file actually has to be present. But in case of W, writing mode, the file does not have to be present. Even if it is not present, a new file will be created and it will be written in that file. Okay, so you might be wondering, what if there is an existing file in case of W? In that case, that file will be replaced by the new file. Okay, so remember, whenever you are using W, be careful so that you don't replace an already existing file. Okay, so the next are RB and WB. So RB is reading in binary mode, and this is not the same as binary stream. If you remember, there were two types of stream, text stream and binary stream. Binary stream is different, we'll learn the difference later on, but this is using character stream but in binary mode, and this is writing in binary mode. Okay, and this is appending in binary mode. And the R plus means you can open a text file for reading or writing, and W means also for reading and writing, but the difference is, in case of read mode you do not open a new file, you open an existing file, and in case of W you open a new file, so you replace any existing files. Okay, so these are two functions that we need to work with files. The first one, which we've already seen, the fclose function. Okay, so whenever you pass the file pointer as argument for this fclose function, it will close that file or close the direction to that file. Okay, so this returns 0 if closing the file is successful, otherwise it returns EOF, which stands for end of file, and usually this end of file is actually just an integer which is -1. So in both cases it is returning an integer, which is why the return type of this function is int. Okay, and this also flushes the buffer before closing the file. So what is the buffer? The buffer is the temporary memory location where, when you are reading from a file, the data is kept. For example, let's say whenever you want to read something from a file, it's 10 characters. So each time you read one character, you have to ask the operating system for access. Okay, and that causes the operating system to become slow. So what happens is, whenever the read operation is gotten, what happens? It reads all the characters until the reading is done or the buffer is filled, and then it writes that, and after that it asks permission again. So the buffer is sort of something which makes the file stream run efficiently. Okay, and the next two functions are used for reading and writing from and to files. Okay, so the getC is similar to fgetC is similar to the getC function, which used to read characters from console. Right, now we are just reading from the file, and fputC used to write putC used to write in console, and now we are using fputC to write into the file. Okay, so there are some arguments here. So as you can see, this file pointer means where we are reading from, and this file pointer means where we are writing to. Okay, and whatever we are reading using the getC, that will be returned as an integer, which is why the return type is integer. And okay, so it's a character, but it will be returned as an integer because characters have ASCII values also, right? And in case of fputC, this ch is the character that we are going to write inside the or in the file. Okay, so they're actually similar to their console versions. The only difference is that they work with a file pointer. Okay, so both these functions get end of file as returns if there is an error or when the end of file is reached. Okay, so you might already be thinking that what will happen if -1 is read, right? So in case of character stream, it is difficult to read -1 because you are reading characters. So minus and 1 will be read separately, right? But even then, what if you are using binary stream or something like that? Sorry, not binary stream. What if you are using binary mode? In that case, we might get -1, right? So to solve that error, there are some more functions. But before going to that, let's see some examples of the functions that we have already learned. Okay, so now we're going to see the basic file or C program. So let's go through the codes first. So this is the header file for the standard input output library, and this is for the standard lib or standard library. Okay, so why do we need the stdlib? Because the stdlib actually contains all of the functions that you'll be using, or rather some of the functions that we'll be using. Okay, so this is the main function, and it is of the argument is void, so we will not be giving any arguments. And this is the string which we'll be using as a test. This is the file pointer, this is the character pointer, then this is an integer which we'll be using to read and write. Okay, so remember, although we're using this integer I, you can also use a character. Okay, so this is opening of the text file.txt for writing. Okay, so even if there is no file, this file will be created. So just to show you, there is no file.txt here. Okay, before we run the program. Okay, so then what are we doing? If we find an error, that means if this whole thing is equal to null, then we cannot open the file and we exit. Okay, then we write to the file. So the very first line is p equal to str. So we are using this pointer to traverse through this whole string. Okay, so while star p, that means while the p is not pointing to the null character at the end, we will keep on writing. Okay, so inside the while loop, if f put c, now we are writing the character star p is the character and fp is the file pointer. So if this whole thing, this function does not return end of file, that means what? We haven't reached the end of file, or there is no error yet. Okay, but if it equals to end of file, that means there is an error. So we'll print error writing file, then exit. Okay, then we are just incrementing p++. Okay, so now you might be thinking, where did we write? So this is where we are writing actually. So when we are checking for this condition, we have already written the character. Okay, and when the character is written, if it is not possible to write, only then it will return end of file, otherwise it will not return end of file. So we are just continuously writing and incrementing this p pointer. So at the very beginning, p will be writing this one, then p++, so h, then the h will be written, then I, then s, then space, then I, s, and so on. Okay, so after everything is written, we are closing the file, and then we are again opening it in read mode. Okay, so if we cannot open it again, we are saying that we cannot open the file, then we are reading it using an infinite loop. Okay, so I is equal to f get c. If I is equal to EOF, that means we found the end of file, then break, otherwise keep printing the character on the screen. So what this should be doing is, this should write this text in a new text file and then read from it. Okay, so at first we have to execute or compile this code, which is basic C. So let's give our commands gcc basic.c -o, and I'm going to give it the same name, which is basic. Okay, so it has been compiled. So now if I want to execute it, I have to just call basic. So as you can see, it is printing it. This is a file system test. But how do you know whether it's not printing it by itself, whether it's actually reading from a file? Let's go back to the location. As you can see, a file.txt has been created, and also a basic.exe has been created. This is the program that we ran just now, and this is the text file. So let's see what is there in the text file. As you can see, inside the text which we wrote, this is the file system test is already there. Okay, so I'm going to stop the class for now here, and in the next part I'm going to show the rest of the files or file function. Okay, assalamu alaikum.